We build telescopes to see the edge of the universe, and microscopes to peer into atoms. But what if reality itself refuses to be explained? Every time science thinks it's reached the truth, reality bends, breaks, or disappears completely. These are the moments when science failed to explain reality. The Double-Slit Experiment. In 1801, English physicist Thomas Young performed an experiment that would forever alter the way we see reality. He shined light through two narrow slits and expected to see two bright bands appear behind them. Instead, he found a pattern of alternating light and dark stripes, ripples colliding like waves of water. Light, it seemed, could behave like a wave, not just a particle. For over a century, that discovery stood as proof of light's dual nature. But the real shock came much later when scientists repeated the same experiment using single photons, individual particles of light. They fired them one at a time, ensuring that no two could interfere. Yet somehow, over time, the same interference pattern appeared again. Each photon seemed to interfere with itself, as though it passed through both slits simultaneously. Then researchers placed a detector to watch which slit the photon went through. The result changed instantly. The interference vanished, replaced by two simple stripes. Observation alone made the photon behave differently, as if it knew it was being watched. This strange behavior became one of quantum physics' greatest mysteries. Some physicists claimed it revealed that reality exists only as probabilities until measured. Others proposed that consciousness itself plays a role in shaping outcomes. After centuries of experiments, the math works, but the meaning doesn't. Observations seem to create reality, not just reveal it. And just as scientists try to understand how looking could change what exists, they stumbled upon something even stranger. Particles that stayed connected no matter how far apart they drifted. Quantum entanglement. Imagine two tiny particles born together in the same quantum event, identical twins at the smallest scale of reality. You separate them, sending one across the lab and the other across the galaxy. Logic says they should now be independent, each living its own microscopic life. But the moment you measure one, the other instantly reacts, as if space and distance mean nothing at all. This is quantum entanglement, the phenomenon Einstein famously dismissed as spooky action at a distance. He believed that the particles must share hidden variables, secret instructions written into their nature before they were separated. But when physicists like John Bell and Alan Aspect put that theory to the test decades later, the results shattered Einstein's assumptions. The correlations between the particles were too perfect, too immediate. No signal, no code, no delay. Somehow the two remained connected beyond the limits of space and time itself. It's as though they were never truly apart, but different reflections of one hidden whole, one fabric of reality woven through everything. Quantum entanglement doesn't just challenge physics. It questions individuality, distance, and even the nature of causality. And if our universe can stay linked across galaxies, maybe our minds can too. Because our next mystery involves people who remember the same moment in history that never existed at all. The Mandela Effect. In 2009, a writer named Fiona Broome attended a conference and casually mentioned how she remembered Nelson Mandela dying in prison in the 1980s. To her surprise, dozens of others agreed, recalling news coverage, funeral clips, and speeches. But Mandela hadn't died. He was alive and well and would later become president of South Africa. The strange moment sparked what we now call the Mandela Effect, a phenomenon where a large group of people share the same false memory. The list only grew. The Berenstain Bears, spelled Berenstein, the Monopoly man wearing a monocle, Luke, I'm your father, instead of No, I am your father. Every example chipped away at the reality of memory itself. Psychologists say it's the brain's tendency to fill in gaps, collective confabulation shaped by culture and repetition. But that doesn't explain how thousands of people can share identical memories that never occurred. Some believe it hints at something more unsettling. Fractured timelines, overlapping realities, or glitches in the simulation we call existence. Whatever the cause, it shows that even our memories, the things we consider most personal, can betray us. And if our memories can lie, what about our measurements? Because the next mystery questions reality itself every time we try to observe it. The measurement problem. In the strange world of quantum mechanics, particles don't have definite positions until they're observed. They exist as probabilities, waves of possibility spread across space. But the moment someone measures them, those waves collapse into a single outcome. The question is, why? This puzzle is known as the measurement problem. It suggests that before observation, reality is undefined, existing in a kind of limbo between potential and existence. But once we look, the universe seems to make a choice. The standard interpretation says measurement forces nature to commit to one reality. But what does measurement actually mean? Is it the presence of a machine, a human mind, consciousness itself? Nobody knows. Every explanation solves one paradox and then creates another. Some scientists think the wave never collapses at all. It just splits, creating countless parallel universes where every possible outcome happens simultaneously. Others believe reality responds only when consciousness interacts with it. Both ideas sound like science fiction, yet both fit the data. The measurement problem stands as a mirror to science itself, reminding us that observation isn't neutral. The moment we look, we change what we see. And the mystery only deepens when you realize that the very thing doing the observing might be the biggest enigma of all: consciousness. You can map the stars, split atoms, and even simulate entire worlds inside a computer. But no one can explain you, the silent observer behind your eyes, the voice that narrates your thoughts, the awareness that feels love, fear, or pain. Science calls it consciousness. Yet even after centuries of study, it remains the greatest unsolved mystery of all. Neuroscientists can trace every electrical signal in the brain, matching activity to thoughts and emotions. They can predict your choices milliseconds before you make them and even trigger feelings using electricity. But no experiment explains why those impulses feel like something. Why does red feel intense? Why does pain hurt instead of simply alerting us? Why does a lump of matter know it exists? This puzzle is known as the hard problem of consciousness, the gap between physical processes and subjective experience. Some argue that consciousness emerges from complexity like heat rising from fire. Others think it's fundamental to the universe, a basic ingredient woven into reality itself. There's even a theory called panpsychism, which proposes that awareness isn't exclusive to humans, and that everything from atoms to galaxies might contain a faint spark of experience. If that's true, then consciousness isn't an accident to biology, but a property of existence itself. No formula, brain scan, or machine has yet uncovered the line where matter becomes mind. It remains the bridge between science and philosophy, maybe between the known and the unknowable. And if understanding the mind weren't difficult enough, the next mystery questions the very stage where consciousness plays out, because time itself may not be real at all. The hard problem of time. We live by time, measure it, and build our entire lives around it. Birthdays, deadlines, heartbeats. Time feels like the most undeniable truth of existence. Yet physics quietly whispers that it might not exist at all. Einstein's theory of relativity reshaped our idea of time forever. He showed that time and space aren't separate things, but threads of one unified fabric: space-time. When you move through space, you also move through time. Slow down your speed and time flows normally. Approach the speed of light and it slows to a crawl. To a photon traveling at light speed, there is no passage of time at all. Its entire journey from emission to absorption happens in a single instant. In this view, all of history, every past, present, and future event already exists, laid out like frames on a film reel. We don't move through time. We simply perceive one frame after another, giving the illusion of motion. Quantum physics complicates things further. The equations that describe particles don't even require time. On the smallest scale, the universe seems timeless, static. Change exists, but the flow of time might be nothing more than a story our consciousness tells itself to connect moments that are, in truth, simultaneous. Physicist Carlo Rovelli believes time isn't a fundamental backdrop, but an emergent property, something that appears only when matter interacts. In other words, time might not exist on its own. It's created by relationships. So if time isn't truly real, neither is the idea of a beginning or an end. And that's where another question begins to rise. If the universe itself is a construct of relationships, what if it was built intentionally? The simulation hypothesis. In 2003, philosopher Nick Bostrom posed a question that turned science into existential philosophy. What if reality is simulated? His argument was simple but unsettling. If technology continues to advance, future civilizations could run simulations of their ancestors, detailed enough that those inside wouldn't know they're simulated. And if it's possible to create billions of such simulations, then statistically we're more likely to be in one than outside of it. Scientists and engineers began to take the idea seriously. Elon Musk once claimed the odds of us living in bare reality are near zero. Some physicists even search for digital signatures in nature, limits in the speed of light, quantum noise, or patterns in cosmic rays that might reveal a computational grid. So far, nothing conclusive. But the theory lingers because it explains too much. Quantum randomness could be system lag, déjà vu, a memory glitch. Reality's constants, lines of code. The deeper we look, the more structured it all seems. The simulation hypothesis doesn't prove we're trapped in a program, but it asks if intelligence and reality are inseparable. And when scientists look beyond the code, they found something even harder to explain: dark matter and dark energy. When astronomers began mapping the motion of galaxies, they stumbled upon a cosmic impossibility. The stars in the outer rims were moving far too fast to be held in place by the visible matter within them. By every law of physics, they should have been flung into the void, yet they stayed bound together. Something unseen was holding the galaxies intact, an invisible glue woven through the cosmos. They called it dark matter, not because it's sinister, but because it's completely undetectable. It doesn't emit, reflect, or absorb light. It passes through planets, people, and instruments without leaving a trace. Yet its gravity sculpts galaxies and bends starlight across the universe. It's everywhere, and nowhere we can touch. Then came the second revelation. The universe wasn't slowing down as it expanded. It was accelerating. Something was pushing galaxies apart faster and faster, as if an unseen pressure was inflating reality itself. Scientists name this unknown force dark energy. Together, dark matter and dark energy make up about 95% of everything that exists. That means all of science, all of human knowledge describes only the remaining 5%, the visible tip of an invisible iceberg. It's a humbling realization. For all our progress, we still live in near total ignorance of the cosmos we inhabit. But maybe that's what makes discovery so beautiful. Every failure to explain reality only deepens our capacity for wonder. And that sense of wonder brings us to the final question: if the universe hides so much from us, maybe its silence is the message. Science was never meant to end mystery. It was meant to chase it. Every failed explanation reminds us that reality is far larger than our current understanding. And still we search, we build bigger telescopes, faster colliders, smarter algorithms, all to understand a universe that might be observing us back. As long as we do, the story of science will never be about what we know, but about how much more there is to discover.